Welcome to section 5.8 and 5.9, inverse trig functions. Okay, this is a little review at first of what we did in pre-AP calculus. When we're talking about inverse trig functions, we are talking about this interval only. Our domain goes from -1 to +1 if you are sine or cosine, -infinity to +infinity, if you are tangent. And then your y values are going to go in between these values in your sine, cosine, and tangent respectively. Now what this does right here is this chops our graph so that we have a little section that is 1-to-1. Now in this section, we always have a quadrant 1. That's where we're going to be positive, and then you have an additional quadrant where your trig function is negative. So with sine, we go to the fourth quadrant in the opposite direction. So there's a quadrant where we're positive and a quadrant where we're negative. Cosine, we have quadrant 1 where we're positive, quadrant 2 where we're negative, 0 to pi. And then tangent, same thing. Now tangent, you can't include those end values, so you won't have a -90, you won't have a +90, or -pi/2, +pi/2. So all this is doing is chopping that infinite graph into a nice little section that is 1-to-1 that has two quadrants, one where you're positive, one where you're negative. All right, so when they ask us to evaluate our inverse trig functions, whenever you're doing an inverse trig function, looking at that value, there's only going to be one answer. If we're talking about the whole entire equation, that's when we have an infinite number of answers. So when you see an inverse trig function, think one answer. Well, arcsine and arctangent are the ones that are the easiest of the two, because positive, you go in the positive direction in quadrant 1. For negative numbers, you go in the negative direction through the fourth quadrant. Okay. Now what that means is if you've got a positive number, your answer is going to be a reference angle. If you've got a negative number, your answer is going to be negative, your reference angle. Okay. So let's look at all of our positives first. So let's look at 4, 2, and 3 here. Now, when we're looking at this, all of our values are positive, so that means we're looking for answers in the first quadrant, because first quadrant's in all of our domains. So I'm actually asking myself, what angle will give me a cosine of square root of 2 over 2? So you're thinking of your special angles unless they let you use a calculator. So square root of 2 over 2, that's our pi/4. Arctan is square root of 3 over 3, so we're looking for an angle who has a tangent of square root of 3 over 3. That's our pi/6. It's our 30-degree guy. Arcsine equals 1. Well, 1, that's not going to be a special triangle, so I want you to think about your graph. Think about your graph from -pi/2 to +pi/2. We're +1, so think about from 0 to pi/2. Where does sine equal 1? At pi/2. Okay? So if you've got a positive number inside your trig function, you're going to have a positive angle for your answer. Okay, now we're going to look at the negative versions. Your sine and your tangent are going to be very similar in the fact that you got a negative number, you're going to be using your negative reference angle. So arcsine is -1/2. You're looking at which trig function is going to have a sine of 1/2. That's going to be pi/6. So negative means we're going through the fourth quadrant in the negative direction. So negative pi/6. Go over to arctangent, -1. Well, which special angle has a tangent of 1? Well, that would be pi/4. Since it's -1, it's going to be negative pi/4. And that's because these guys are positive in quadrant 1, negative in quadrant 4, and we are hitting quadrant 4 going backwards. So arcsine and arctangent are going to be the easiest of the two. Cosine, arccosine is negative in the second quadrant. So I'm going to have to find my reference angle. which in this case, cosine square root of 3 over 2, that's my 30-degree guy. So that's pi over 6. Arc cosine is negative in the second quadrant, so I'm going to have to take pi minus my reference angle, which is 5 pi over 6. So cosine is going to be a little bit more work because it's positive in the first quadrant, negative in the second quadrant. Now, when we have an inverse trig function and a trig function, we're going to have a little bit more work to do. Not a problem, though. When you're looking at these, you're going to look to see, wait a minute, is this a special angle or is it not a special angle? Well, square root of 2 over 2, square root of 3 over 2, 1/2, square root of 3, square root of 3 over 3, those are all special values. So when I go here, I'm going to start on the inside, just like we do with all algebra. And I'm going to ask myself, which angle has a cosine of positive square root of 2 over 2? It's positive, so I know I'm in the first quadrant. So I get to use my reference angle. That's going to be pi over 4. So there's the inside part. Now I want to find the tangent of pi over 4, which is 1. So final answer is 1. Now on problems like number 8 and number 9, these are not going to give us special angles. So what we'll want to do is we'll want to find this answer, okay, by using my triangles. So we're going to let this be u. So u is equal to arc sine of 5/13. Well, we're going to sine both sides because we want to work in a triangle. So if we sine both sides, sine and arc sine cancel each other out. So I end up with the sine of u is equal to 5 over 13. Now that I have my trig function, I can draw my triangle. I'm going to put u right here. Sine is opposite over hypotenuse. I just need to find that missing side. Well, that's a Pythagorean triple. So I know that missing side has to be 12. So everything in that parenthesis is u. So really, we're just asked to find the cosine of u. All of this right here is u. So we're asked to find the cosine of u. We now have a triangle set up. Cosine is adjacent over hypotenuse. So that's just going to be 12 over 13. So my answer is 12 over 13. So even if it's not a special angle, we can still get through it. Now number 9, the only thing that's different is we have a negative on the inside, so we have to remind ourselves what kind of answer we're going to get. So look at the inside, arc sine is negative, so this negative right here tells me arc sine, that angle is in the fourth quadrant. Well, what do you know about the tangent of an angle in the fourth quadrant? Okay, that's going to be negative. So my answer is going to be negative, whatever we turn out to equal. So once we figure out our answer is going to be negative, we're going to let what's inside be u. So we're finding u equals arc sine, excuse me, negative 5/6. I don't need the negative anymore because I've already decided the negative told me I was in the fourth quadrant. Tangent's negative in the fourth quadrant, so I don't need that negative anymore. I'm going to sine both sides just like I did in the other problem. Now I get to draw my triangle. This one's not going to be as much fun because it's not a Pythagorean triple. I have to take 6 squared is equal to 5 squared plus my adjacent side squared. So 36 minus 25 is 11. Square root of 11. Okay, so I'm really being asked to find the tangent of u. Because remember, everything in that parenthesis we substituted out as u. I know my angle's in the fourth quadrant. Tangent's negative there. It is opposite over adjacent, so 5 over the square root of 11. Whether you want to rationalize that or not, that's totally up to you. Okay. Now, 10 and 11, same process. We're only going to do one of them. If you want to try the other one and then I can tell you what the answer is at class, that would be great. We're going to do the same thing. It's going to be everything inside is going to equal u. So u is going to equal arctangent. Remember, arctangent, that's just another way of saying the inverse of tangent. So we're going to tan both sides. That makes that inverse tangent cancel out. Now we need this to be a fraction because the definition of tangent is opposite over adjacent. So I'm going to make that into a fraction just like I do anything else. I'm going to put it over 1. Now I can draw my triangle. Now we don't have to worry about what quadrant we're in because we don't know. It depends on what they give us for x. For x, we don't know if that's positive or negative, so we're just kind of in a holding pattern until they tell us otherwise. So this side's going to be my 4x because that's my opposite side. My adjacent side is 1. So that means this side is going to be 16x squared plus 1. Remember, everything inside is u, so we're actually just finding the cosine of u, which would be 1 divided by square root of 16x squared plus 1. Okay, so 11, give that a try. I'll give you the answer in class. So for the rest of the video here, we're going to find the derivative of inverse trig functions. And here are my little formulas right here. I have them all copied down, and they're provided for you in your notes. So we're going to go right to what happens if I forget one of the formulas. Okay. Well, if I forget one of the formulas, we're going to do that very much like we did that last example. We've got y equals arcsine of u, so we're going to sine both sides. If I sine both sides, I've got this 2u, because sine and arcsine cancel each other out. We're going to put that over 1 so we can draw our triangle. So we know this is y. So this is going to be u, because that's opposite over hypotenuse. So that means this side has to be the square root of 1 minus u squared. So we've got our triangle set up. Well, they want us to find the derivative of an inverse trig function. So we're going to take our sine of y equals u, and we're going to take the derivative of that. Well, the derivative of sine of y is cosine of y times the derivative of y, dy over du. The derivative of u is just going to be that, here, let me go back, okay? So that's going to be dy over du. That's going to be 1. So I want to separate that. Remember what we did before? Okay. Now, I really want this to be in terms of dy. So I'm going to have to divide through by cosine of y. I would like this to all be in terms of y. I'm sorry, all in terms of u. So that cosine of y, I'm going to substitute that out using my little triangle here. Well, when I do that, I've got that dy equals du over the cosine of y, that's your adjacent side over your hypotenuse, so that's going to be the square root of 1 minus u squared. And if you go back to your definition, that's exactly what it is. Okay, and this u prime is just the derivative du. Okay, same thing. Okay, so if you forget your formula, whatever that arc trig function is, do that trig function to both sides, draw a little triangle, find the derivative, plug that cosine out of there so you have nothing but u's, and you're ready to go. Because once you know those formulas, this becomes super easy. When you're looking at your formula, you've got the derivative of u over the absolute value of u times the square root of u squared minus 1. I just need to find out what that u is. There's u right there. So u is equal to e to the 2x. You need to find du by taking the derivative, which is going to be 2e to the 2x, and then you plug those values in. So my derivative is going to be du. Remember, u prime is du, so that's 2e to the 2x. okay, divided by the absolute value of u. I don't need to put e to the 2x in absolute value because it is going to be positive. And then e to the 2x squared, let me just rewrite it, minus 1. And then simplify as much as you possibly can so that e to the 2x, that's going to cancel. So that secant's pretty neat. That cancels. It's pretty neat when you have exponentials, rather. So exponentials do extra canceling. E to the 2x squared is going to be e to the 4x, and then minus 1. So once you know those formulas, it's going to be super easy for you to find the derivative. And if you forget those formulas, you can always recreate those. Now arc sine, that one's a nice one. It's one that you're going to be using a lot of. So that's going to be your u prime over the square root of 1 minus u squared. So my u this time is going to be 2x. My du is just 2. So when I make my little formula out, I'm going to have du, or u prime, divided by the square root of 1 minus u squared, which is 2 over square root of 1 minus 4x squared. Let's do one more, and then I'll let you get back to your activities. Tangent. Now tangent is nice because it's one of the only ones that are adding. So you've got u prime is equal to 1 plus u squared. So u is going to be square root of x, which is really x to the 1/2 power. So du is going to be 1/2 x to the negative 1/2 power, which is 1 over 2 square root of x. When I fill in my formula, I've got 1 over 2 square root of x, it's du, plus 1 plus u squared, which is going to be x. And then it is good if you flip and multiply, try to get rid of your compound fractions. So I'm going to put that over 1. There's my division bar. And I'm going to flip and multiply. So I will have 1 over 2 square root of x times 1 plus x. Now as you go through this video, I want you to just kind of quickly look back at what our answers looked like and where we started. Okay, because this is where we ended up after we simplified. This is where we started. Especially true about your secant, especially anytime you have e to the whatever power as your u. Look where we ended up. Look where we started. We had that e to the 2x on the bottom. We had an e to the 2x on top. So that's simplified. So now for tomorrow's video, when we integrate, we're going to be starting here. So keep that in mind for tomorrow's video. So 5859, differentiation. See you in class tomorrow.